WHONET Training Course Module 6, Quick Analysis Reports. In Modules 4 and 5, you have seen the features for interactive WHONET analysis, where you choose the organisms, antibiotics, and filters and view the results. We will now move on to Quick Analysis, where the analysis details and options are defined in advance, either by the WHONET team in Boston or by your local staff. We will review 6 sections. A. Introduction to Quick Analysis. B. WHONET Standard Reports developed for the screen and Microsoft Excel. C. WHONET Standard Reports developed for Microsoft Word. And D. User-defined reports. In Section E, we will briefly describe WHONET's features for exporting data to the DHIS2 surveillance platform. And in Section F, I will briefly comment on the use of the WHONET automation tool to schedule daily, weekly, and monthly reports. More detailed documentation on WHONET's DHIS2 features and on the WHONET automation tool can be found in the WHONET Training Center. Benefits of WHONET Quick Analysis Reports. WHONET can create automatic reports which combine the results of several analyses into a single output. Reports can be shared with partners in the laboratory, pharmacy, infectious disease, infection control, national authorities, collaborating organizations, and funders. WHONET macros and reports save time and promote consistency with repeated analyses. One WHONET user can create reports for many other WHONET users, which promotes standardization and collaborative discussion of results, both within a single institution and across many institutions. WHONET reports can also be automated to run on a periodic basis, for example, daily, weekly, or monthly. On this screen, you can see some examples of outputs from WHONET Quick Analysis. In the first 2 images, you see that WHONET can create reports optimized for display on the screen or exported to Microsoft Excel. In the third image, you can see that WHONET can also create reports that have been optimized for Microsoft Word. With regards to interoperability, WHONET has the ability to export data to other systems. The first image represents a PDF file created by the free AMAS software developed by the Mahidol Oxford Tropical Medicine Research Institute in Bangkok, with data exported from WHONET. The second image displays a dashboard of WHONET results that have been exported into the widely used DHIS2 Public Health Surveillance Platform, an international collaborative project managed by the University of Oslo in Norway. We will now review the steps for creating a quick analysis report. First, start WHONET, choose your laboratory, and click on Open Laboratory. Then on the main screen, select Data Analysis and Quick Analysis. We now see the options available in Quick Analysis. There are 3 sheets with the names WHONET Standard Reports, User-Defined Reports, and DHIS2. We will start with a discussion of the WHONET Standard Reports. On this screen, I can choose the report that I would like to run. For this demonstration, I have clicked on Organism and Antibiotic Statistics. I can then select the data files that I would like to analyze, and we will see this on the next screen. Finally, I can choose between presentation of the results on the screen, in Excel, or in Word, and then I can click on Begin Analysis. We will review each of these steps. After I click on Data Files, I can see the data files that are available for analysis. You can choose files from a single laboratory if you would like, or if you are a national data manager, you can select files from many laboratories to get a national report. In this example, I have selected a single file for the analysis. You can now see here the data file or data files that I have selected. I can choose whether to send the results to the screen, Excel, Word, and a number of other options. However, some of these reports were specifically developed to be viewed on the screen or in Excel, while others were specifically designed for Microsoft Word. Now that we have selected the report, the data files, and the output, I can click on Begin Analysis. On the previous screen, I selected the report for organism and antibiotic statistics. And on this screen, I can see the first page of that report. In this analysis, we see the list of organisms in the rows and the different laboratory codes in the columns. Because I selected data files from a single laboratory, you only see one laboratory column. But if I had selected data from multiple laboratories, there would be one column for each laboratory. On the screen, I have clicked on the laboratory code in the lower right of the screen, so I can now see the distribution of the different organisms for this laboratory in the graph. In this example, you see that there are 4 tall bars representing the 4 most common organisms. If you wish to export your results to Excel, Word, or PowerPoint, you can use the same options that we saw in Module 4. Include Copy Table, Copy Graph, Save Table, and Save Graph. When you finish reviewing the results of this analysis, you can then click on Continue, Continue, Continue to advance through the other analyses included in this report. We'll review these options further later in this module. After you click Continue for the final analysis, you will return to the main screen for quick analysis. You can then choose a different report, or you can repeat the same report with other data files. On this screen, I also have the ability to choose a specific date range. As you can see in the right of the screen, I have selected dates from June 1st, 2000 until June 30th, 2000. The ability to choose specific dates is useful in 2 circumstances. 1, you have an interest analyzing a very specific period of time. And 2, exclude incorrect dates that may be due to typing error mistakes, for example, specimens from 1970 or 2040. Section B. I will now focus on the WHONET standard reports that were developed specifically for the screen and for Excel. The WHONET team has developed 3 standard reports for the screen and for Excel: patient and sample statistics, organism and antibiotic statistics, and isolate alerts, which we will see on the next 3 slides. The report called Patient and Sample Statistics performs the analyses mentioned here. WHONET presents the number of isolates and the number of patients for each laboratory by month, by sex, by age group, by location type, and by specimen type. This analysis provides a simple demographic overview of the patients, their samples, and their locations. You can see the tables and the graphs on an interactive screen or save the results to an Excel file. On the right, you can see 2 examples: the distribution of locations as it would appear on the screen, and the distribution of specimen types as they would appear in an Excel file. The next report is called Organism and Antibiotic Statistics. This report presents summaries of the priority laboratory results. First, WHONET will show the distribution of organisms by many variables: laboratory, month, sex, age group, location type, and specimen type. In the first image on the right, we see the graphs for the number of patients for each microbial species in cardiology, cardiac surgery, and the emergency room, saved in an Excel file. For antibiotic results, WHONET provides the detailed %RIS reports for Staphylococcus aureus and Escherichia coli, as well as the summary for gram-positive and gram-negative antibiograms. In this graph, we see the distribution of diffusion results for Escherichia coli and ampicillin as they would appear on the screen. The next report is for microbiology alerts. This report first looks at isolates with alerts of public health importance, such as important species and important resistance. In the first table, we see a listing of isolates with alerts that appear in red. For example, in the last column, we see that several isolates are resistant to cefotaxime. At the bottom of that table, we also see 2 isolates that are resistant to amikacin. WHONET then analyzes the files again looking for isolates with quality control alerts for findings that might suggest errors in the test results. In the table, we see a summary of how many isolates are found with each alert. This could include isolates of Klebsiella pneumonia, which are susceptible to ampicillin, or isolates of Escherichia coli that are susceptible to amoxicillin, but resistant to amoxicillin clavulanic acid. Laboratories should validate both the organism identification and the antibiotic results to ensure that there are no errors. For reports that were optimized for display on the screen or export to Excel, there are a number of advantages. There is a variety of distinct analyses with comprehensive details, such as all locations, all specimen types, all organisms, and all antibiotics. On the screen, the output is interactive, so you can select any graph. In Excel, the raw data are available if you would like to modify the output content or formatting. But there are also disadvantages. No explanatory text is provided. The extra details are of great value to the primary data analysts, but can be overwhelming and unneeded by colleagues and other stakeholders who would often prefer a shorter presentation which highlights and discusses priority findings and conclusions. Also, the format of Excel tables and graphs is not convenient for printouts that can be shared with others. The WHONET team has developed a number of reports for Microsoft Word. In this presentation, we will review the epidemiology report and the test practices and data quality report. On this screen, you can see a high-level overview of the epidemiology report. As you can see, the report has a mixture of tables, graphs, and text divided into different sections. This is a convenient report that you can share with laboratory and pharmacy staff, the infection control team, and national authorities. We will now look at the report in greater detail. Here we see the first 2 pages of the report, including the table of contents. The report has sections on data volume, patient and sample details, organism statistics, antibiotic statistics, WHO and Sustainable Development Goals, cluster detection, and antibiograms. There is a section in the epidemiology report for patient and sample statistics. Analyses indicate the number of patients by laboratory, year, age groups, sex, locations for specimen collection, and the specimen categories. Figure 2 presents the age distribution for male and female isolates, while Figure 3 summarizes the distribution of specimens by category, such as urine, respiratory, blood, and soft tissue. Analyses included in the section on organism statistics include the distribution of organisms by month and by specimen category, and a summary of important species of high priority, such as Neisseria meningitidis, and medium priority, such as Salmonella enteritidis. Figure 4 presents the distribution of the 5 most common species identified in each specimen category. In Table 7, we see a list of organisms found to have statistically significant increases in numbers over the course of the year. The section on antibiotic results has several parts summarized on the next 2 screens. There are tables for isolates with important resistance and aggregate antibiograms for gram-positive and gram-negative organisms. Table 13 displays the list of specific resistant phenotypes identified by WHO as critical, high, and medium priority for purposes of new drug development. WHONET also includes the statistics requested by the WHO GLASS AMR module and the UN Sustainable Development Goals. On the next slide, we will see statistics about multi-drug resistance. The study of multi-drug resistance has important implications for therapy options, advocacy, and detection of possible outbreaks. The epidemiology reports looks at multi-drug resistance in 2 ways. In Table 10, we see the categorization of priority species as multi-drug resistant, extensively drug resistant, and pan-drug resistant, also known as MDR, XDR, and PDR. These definitions are based on the number of antibiotic categories to which the isolates are non-susceptible. Table 11 provides a more precise view of multi-drug resistance by categorizing isolates according to the specific antibiotics to which an organism is non-susceptible. This approach offers great value for the detection of hospital and community outbreaks. One of the most valuable features of WHONET is the detection of possible disease outbreaks in community and hospital settings. WHONET accomplishes this through integration with the free SAT-scan software for the detection of case clusters. In Figure 5, we see statistically significant numbers of patients in 2 bacterial species appearing in vertical red bars. For the graph on the left, we see that there is a statistically significant increase in the number of patients, and one explanation of this could be a disease outbreak. In the graph on the right, there was a large increase in the number of patients in March. This could also represent a disease outbreak, but such a large increase in coagulase-negative staphylococci may also suggest a problem of contamination of the clinical samples or laboratory reagents. Other possible explanations for an increase in the number of cases could include changes in sampling practices or laboratory procedures, changes in the patient population served, or simple random variation. We have finished discussing the epidemiology report. We'll now review some of the analysis features available in the test practices and quality report. On this first screen, you see a high-level overview of the report with a mixture of text and graphs and tables with multiple sections. We will now move on to the contents of the report on test practices and data quality. In the table of contents, you see there are sections for data entry and management, quality control results, organism results, antimicrobial susceptibility test practices, and quality control alerts. On the next slides, we will see examples of some of the analyses that are included in this report. The report addresses quality from a few perspectives. In this first slide, we see statistics about the completeness of data entry for priority data fields and the use of valid WHONET codes. In this particular database, I see that 100% of the isolates have the priority variables entered, but only 96% of the samples have a valid value for the specimen type. In this slide, we are looking at quality from the perspective of laboratory capacity. In Table 3, we can explore the laboratory's capacity for the identification of bacterial species. In this example, we can see there are 35 isolates of Klebsiella, and the laboratory identified the species in all 35 isolates. On the other hand, in 82 isolates of Enterococcus, the laboratory only determined the species once. The findings suggest that the laboratory has good practices for the routine identification of gram-negative organisms. However, for this gram-positive organism, testing is primarily done by manual methods with a genus-level identification. In Table 4, we explore the ability of the laboratory for isolating and identifying fastidious organisms. For example, I see the laboratory identified 24 isolates of Haemophilus influenza and 2 isolates of Neisseria meningitidis, but I see no examples of anaerobic organisms. This quality report also shows statistics on test practices. In Table 7, we see a list of antibiotics that were tested but which do not have official breakpoints. Specifically, there are no breakpoints for Staphylococcus aureus and the vancomycin disc test. Therefore, this antibiotic generally should not be tested. In Figure 2, we can look at the regularity of testing. I can see that most of the antibiotics were tested 76 times. However, nitrofurantoin was only tested 14 times, which is not a surprise as this antibiotic is primarily utilized for the treatment of urinary tract infections. So this analysis allows me to explore 2 issues. 1, appropriateness of testing. Is the laboratory performing any invalid antibiotic tests? Could the list of antibiotics be improved? And 2, regularity of testing. Are all antibiotics tested on every isolate, or is there selective testing depending on the specimen type or the patient location? Does the laboratory routinely test a set of first-line antibiotics on all isolates and then a second-line antibiotics on multi-resistant isolates? Are there problems with reagent outages in the laboratory? In Table 10, we see a summary of the quality alerts for infrequent or unlikely test results, such as Klebsiella pneumonia susceptible to ampicillin and Escherichia coli susceptible to amoxicillin but resistant to amoxicillin clavulanic acid. The WHONET reports designed for export to Microsoft Word have a number of advantages over reports designed for the screen in Excel. They focused on the highest priority results, for example, the top 10 organisms with a lot of explanatory text. The report has attractive formatting, and it can be easily printed and shared with local, national, and international colleagues. There are also disadvantages. The focus is on certain priority results, so this report has less detail than what we saw in the Excel reports. The content and formatting of the Word report is defined by the WHONET team. If you wish to make changes to these reports, you must make these changes manually in Microsoft Word. To address some of these limitations, the WHONET team plans to make improvements in the Word reports in the future. For example, we plan to offer some ability to configure some features of the Word reports, such as logos, text, and filtering criteria. We also plan to create a new section for highlights and recommendations. In Section B and C, we reviewed reports that were prepared by the WHONET team for your use. They are simple and convenient. However, you cannot change them. Now in Section D, we will look at the creation of user-defined reports. You can create daily, weekly, monthly, quarterly, and yearly reports, and you can customize these for the pharmacy, the infection control team, national authorities, and other collaborators. We can see the sheet for user-defined reports here. When you begin WHONET, there are no user-defined reports, but you can create your own using the option New Report. A user-defined report in WHONET is a collection of WHONET macros, which were discussed in Module 4 of this course. So before you create a new report, you should return to Interactive Data Analysis to create a series of macros that you would like to include in the report. For example, in Module 4 of this course, we created a macro with the name %RIS, SAU, and ECO first. In the below example, I have created additional macros with the names gram-positive antibiogram, gram-negative antibiogram, and gram-negative antibiogram in urine. After you click on New Report, you will see the below screen. On the left, you will see all of the macros that you can find in your WHONET macros folder. First thing that I will do is to create a name for this new report that I would like to create. For example, I will type the name Antibiogram Report. I can then select the analysis macros from the left of the screen and use the arrow to move them to the right of the screen. In this example, I have selected the 3 macros related to antibiograms. I can use the move up and move down options for changing the sequence of the macros. You can also use the option Browse to change the folder to choose macros from another file location. Click on Save when you are finished to save the report name Antibiogram Report. Click on Save again to save the report file. The default name suggested by WHONET is antibiogramreport.rpt, and the default file location is C WHONET macros. You can change this if you wish. When finished, click on Save to save the report, and then exit to return to the main menu for quick analysis. On this screen, you can now see the new report that we have just created with the name Antibiogram Report. There are other useful options that appear on the screen: edit, rename, delete, and copy. You can also click on Browse if you would like to select a report file saved in another folder. I've selected a single data file for analysis, and I'm now ready to click on Begin Analysis. When you click on Begin Analysis, you will advance to the first output of your report. Then click on Continue to advance to each of the next ones. Or if you want to end the report quickly, click on File and Stop Analysis to end the analysis immediately. In this example, I have exported the results to the screen, and I am reviewing the results for the gram-negative antibiogram report. I have sorted the table by frequency, so the most common organisms appear at the top of the table, and I have selected Escherichia coli for the graph. Instead of choosing Screen for the output, I can choose Excel. WHONET proposes the name of the new Excel file that you will create. By default, the file name will include the name of the report and the date that you performed the analysis, and the file will be saved in the WHONET output folder. Click on Begin Analysis. When WHONET finishes the report, it will ask you if you want to open the Excel file. Select Yes. If you do not see the report immediately, then click on the Excel icon at the bottom of your screen to see the file. There will be one Excel sheet for each analysis. On this screen, we see the list of user-defined reports that we have created on the left. You also have the ability to edit these reports by clicking on Edit Report, as we see to the below right. You will now return to the screen that we saw earlier, where you can add additional macros to the report or remove macros that you no longer need. When you're finished modifying the report, click on Save and Exit. On the previous screen, we saw that we can use WHONET to modify reports that you have created. WHONET report files are simple text files, and they can also be conveniently edited with any text editor, such as Notepad. This can be very useful for national data managers or any data analyst managing many macro and report files. Edit reports in this way. Find your report files in your WHONET macros folder, as you can see below left. You can edit one of these existing files. Or in Windows, you can use Copy, Paste, and Rename to create a new report. Open the report that you wish to edit in Notepad, as you can see below right. The first row of the report file indicates the name of the report. This is then followed by the names of the macro files that should be included in this report. It is very simple to create backups of these reports or to share them with other colleagues. By default, WHONET and report files are stored in the WHONET macros folder. From here, you can make backup copies, and you can send them to your colleagues by email. Reports only contain a list of macros. They have no confidential information in them, so they can be shared freely with collaborators. I mentioned earlier that the reports are saved by default in the WHONET macros folder, but you can change this. As we saw in Module 4, you can go to WHONET main menu, click on File, click on Configuration. You will see the default location for each type of file. By default, macros and reports are saved in the WHONET macros folder, but you can click on Browse to choose a different folder location. User-defined reports offer a number of advantages over the WHONET Standard Reports. Most importantly, you can define your own macros with the organisms, filters, and options that you need, and these can be customized depending on the priorities of your local and national collaborators. You can send the analysis results to the screen or to Excel files that can be shared with your colleagues, and you can share the macro and report files with other WHONET users. There are some disadvantages to the user-defined reports, as you must create the macros yourself. Also, at the present time, you can only export user-defined reports to the screen or to Excel. You cannot create your own user-defined reports for Microsoft Word, but we hope to offer this possibility in the future. We will now move on to a brief introduction to the WHONET DHIS2 analysis features within Quick Analysis. DHIS2 is a widely used web-based data visualization and analysis platform used by ministries of health for public health surveillance. It is used by many countries for tracking statistics for patients with malaria, tuberculosis, HIV, COVID, diabetes, and anemia. DHIS2 is commonly used to organize and track antenatal care visits and childhood vaccinations. There are few examples where DHIS2 has been used for surveillance of antimicrobial resistance. but the new WHO GLASS platform is built on the DHIS2 platform. DHIS2 is an international collaborative activity that is managed by the University of Oslo in Norway. The DHIS2 features of WHONET will be covered in a separate training module. On this screen, you can see that quick analysis includes 3 reports for exporting data from WHONET to DHIS2. This slide illustrates the steps needed to export data from WHONET to DHIS2 dashboards. 1. I can export results from WHONET to DHIS2 export files. 2. I then import these results into DHIS2. 3. I can see the data that I have uploaded in DHIS2. And 4. I can analyze and visualize the results in DHIS2 with maps and charts. For further information about DHIS2, there is a WHONET DHIS2 manual describing these features. Finally, I will give a few brief comments about the WHONET automation tool. The WHONET automation tool supports automated analyses, for example, on a daily, weekly, or monthly basis. These can include alerts for important isolates or possible outbreaks, and there can also be alerts for data quality issues or data feed issues. Steps that can be automated include backlink, WHONET, file backups, event monitoring, and email notifications to data managers, laboratory staff, infection control teams, and national authorities. 2 screens of the WHONET automation tool are shown here. The user interface is seen to the bottom left, whereas an example of a monitoring graph is shown to the right. Thank you for watching Module 6, and congratulations, that concludes the WHONET training course. Thank you for your time.